All right, we're going to do lesson 4.3, proportional relationships. I can graph proportional relationships is the I can statement. Sometimes you'll hear them talk about proportional relationships as direct variation. So the graph of a proportional relationship is a line with a slope, and the slope is m, that passes through the origin. And we can look at the equation for a proportional relationship as y equals mx. Usually we've been used to doing y equals mx plus b, where you'd have that y-intercept at the end. The y-intercept in proportional relationships are 0. And you won't find that 0. Mathematicians won't write the plus 0, but just know that that would be there, and that would be the y-intercept. So let's look at these 4 examples here, and we have to determine which ones are proportional. So we're looking for graphs that go through the origin. So if I look at A starts at the origin, that would be a proportional relationship, or a direct variation. B, as I look at B, this does not go through the origin, so I would say that that's not a proportional relationship. C is close. If we zoom in, we can kind of see it's close, but it doesn't go through, so C is not. And then D does start with the origin, and it goes through the origin, so we would say that D. So the answer to this would be A and D are proportional relationships because they both go through the origin. We can do this without graphs too. We can look at a table. So if I look at this table, I would have to determine if I continued the table, would it go through 0, 0? So I can kind of follow the pattern 4, 3, 2, 1. I'll just put it over here to the left, 0. And then this pattern looks like it's counting by 110. So it drops from 420 to 310. That's 110, 110, 110. If I subtract another 110, I would end up at negative 20. And what I'm looking for here is I'm looking for 0, 0 to be one of my points. And in this case, it is not. The point would have been 0, negative 20, but not 0, 0. So I would say that this is not a proportional relationship. Let's look over at F. So I'm following the pattern. 2, 1.5, 1, 1/2. It's counting by half, so my next would be 0. And then 4, 3, 2, 1, that's counting by ones. My next would be 0. So I would say that that goes through the origin 0, 0. So F would be a proportional relationship. All right. So let's graph a proportional relationship, or direct variation. So we're going to graph this just like we've been graphing other equations. We're going to make an XY table. The only thing different here is my equation, which is y equals 10x, does not have a y-intercept. It's not like 10x plus something. It's just y equals 10x. So I'm going to pick values for x. I can choose, it looks like the graph that I have set up here is all positive. So a lot of times I'm going to be able to choose negative numbers, but in this case I'm just not. And I'm going to start with 0, and then I'm just going to go 1, 2, 3, and then let's graph it from here. So plugging it in, this would be 10 times 0, which is 0, and then there is my 0 point, which would make it a proportional relationship. And then I'll just fill this in 10 times 1, 10 times 2, and then 10 times 3. Oops, why did I put 0 on all those? Sorry for the mistake there. This should have been 1, 10, 2, 20, and then 3, 30. There you go. To graph this now, I'm going to graph those points. So 0, 0. We'll call this 1. I'll set my graph up it by tens here. 10, 20, 30. And so 110 would be right here, 220, and then 330. And then if I extend this in that direction, that would be that line. And now on to the second part of this. This is if the cost of an internet plan was y equals 10x. If I look down below, it's asking me to graph it if it was y equals 5x. So I'm going to do the exact same thing I did above. The only thing I'm doing now is instead of using the equation 10x, I'm using 5x. So if I were to pick points, 0 for x, if I plug that into the x value, it's going to spit out 0 for y. If I plug 1 in, and I'm doing that by plugging it in, I'll draw a line here, plugging it into that x. If I plug 1 in there, 5 times 1 is 5. And then if I plug 2 in, 5 times 2 is 10. And then 3, 5 times 3 is 15. That's enough points to graph. So let me graph these. So 1, 5, well 0, 0 would be here, 1, 5, 2, 10, and then 3, 15. If I continued the pattern, I would go 420 and so on. And I'm going to get a line that looks like this. So that's an example of the two internet plans. What plan costs less? Let me answer this question at the end. Well, it looks like the plan where it's y equals 5x costs less. So I would say that that one does.
Interruption. Ronald Russell, please come to the office.
All right, example 2. The weight on Saturn's moon Titan, y, is proportional to the weight of an object on Earth. A 105-pound object on Earth weighs 15 pounds on Titan. Use the point 105.15 to find the slope. So this is a proportional relationship. I do know that if it's a proportional relationship, it's going to go through 0, 0. So I can have 0, 0 as one of my points, and then 105.15 as the other. And if that's the case, and I have 2 points, I can always find the slope of those 2 points by subtracting the y's on top and the x's on bottom. So the top would be, I'm just going to take my y values, which would be 15 and 0. I'll highlight those. That's where I get the 15 and 0. Those are the y values. And then the x values are the ones that go with it. So 105 and 0. So 15 minus 0 is 15. 105 minus 0 is 105. And that looks like something that can be simplified. So I'm going to get my calculator out, and I know I can divide both by 5. So let me start with that. So I divide both by 5 to simplify, and I get 15 divided by 5 is 3. 105 divided by 5 is 21. And 3 over 21 appears that can be simplified. And I know 3 goes into both of them, so I'm going to continue to do this. 3 divided by 3 is 1, and 21 divided by 3 is 7. So the slope of this line would be m equals 1/7. Okay. The second part about this is how much would ice that weighs 3.5 pounds on Titan weigh on Earth? So if we go back to this previous example, my slope, which is m equals 1/7, I can set the equation up as y equals 1/7 x. I just found the slope, which is 1/7. And then from here, I can figure out how much ice that weighs 3.5 pounds on Titan weigh on Earth. And if you look back at the original problem, Titan was my y value, and Earth was my x value. So I'm going back to the top here. And if Titan's my y value and the ice weighs 3.5 pounds on Titan, I would take 3.5 and plug it into y and set that into the equation and solve for x. So I have the equation 3.5 is equal to 1/7 x. When there's one term on each side, it's time to divide. Another way to eliminate the 1/7 would just be to multiply by 7 on both sides. The 1/7 and the 7 cancel out, and that leaves me with x is equal to 3.5 times 7, which ends up being 24.5 pounds. So what that says is that ice that weighs 3.5 pounds on Titan actually weighs 24.5 pounds on Earth. All right, still doing a little bit more with this lesson. Let's compare slopes. So there's 3 different ways that we can find slope, and one of the ways is just to look at the number in front of x when it's in slope-intercept form. So because this equation is in slope-intercept form, because it's y equals mx plus b, I can just take the slope from it. So the slope of this 4-person ski lift would be 2.5. The slope of these 2 points, the 2-person ski lift, because they're points, I can set them into the slope formula by subtracting the y's on top. I'm just going to go big number minus little, and then I've got to keep the same order. So if I do 12 minus 4 on top, subtracting the y's, I have to do the same order on bottom. 12 minus 4 is 8, 6 minus 2 is 4, 8 divided by 4 equals 2. So the slope of that equation is 2. The slope of the previous equation was 2.5. And then the 1-person lift, I have a graph. So I'm going to take rise over run. I can just take 2 of the points off the graph. I don't have to choose specific points, but I'm just going to take these 2 that I highlighted in yellow. And then I'm going to do rise over run. And the rise would be going up 1, 2, 3. So that's a rise of 3 and a run of 1. 3 over 1 is just 3. So the slope there is 3. Which ski lift is the fastest? So which one has the greater slope or the steepest slope? That would be the 1-person ski lift. Then followed by the 4-person lift at 2.5, and then the 2-person lift at the slope of 2. All right, let's finish this off with the homework ticket. Tell whether x and y are in a proportional relationship. So this is the main thing we learned today. And if you look at this graph, you can see that it does go through 0, 0. And so then A would, yes, be proportional. If I look at B, I'm looking for the point 0, 0, and I don't have it. I have the point 0.04. 0.04 is not good enough for proportional relationship, so it's not. And then C, this one takes a little bit of work because I don't know if I have the point 0, 0. I can look at a pattern here, and the x values count by 4, 3, 2, 1, and then 0 would be right here. Oops. And then 20, 15, 10, 5, this is counting by 5s, and that goes to 0. So I do have 0, 0. C would be a proportional relationship.